Today I'd like to talk a little bit about whether we should consider chemicals, and in particular volatile chemicals, in our biological control practice. To make a case for chemical ecology quickly, chemicals play an important role, as you know, in terms of mediating insect and plant interactions. We know that insects, many of them, are not highly visual creatures. They use smell or olfaction to locate their host. And so, therefore, chemicals that are emitted by plants traveling up to them are very important for them to locate the actual host. But these volatile organic chemicals may be induced in response to damage. So whether this is biotic or abiotic damage, and this can be expressed in two different ways. Either the quantity of the bouquet of volatile chemicals that is emitted can be increased, that is, in other words, the intensity of the smell, or the quality. In other words, when the plant has been induced, you have different types of chemicals that are coming up in that plant. And these have been noted in literature to have anti-feeding, repellent. They also can help in plant-to-plant communication. So one plant that's damaged can actually prime another plant that is undamaged, and it then can increase its allocation of defenses in anticipation for defense that's coming up. But they can also act as cinnamons. Cinnamons are chemicals that act as mutualistic chemicals. So in other words, when the plants have been damaged, they send out signals, and the natural enemies of the herbivores can then use those signals to find them and to feed on them. So this is very widespread in literature. It's well known, it's well accepted. And what I'm trying to hopefully get across to you is that if we can understand the incidence of these induced plant responses in biological control, just as it is important in plant-insect interaction, it may be that it is very important also in biological control of weeds. If they're important for the chemicals are important for insects, then perhaps they are also important in biological control. So my case is Lantana, camara. That's my case study. I'm not going to dwell a lot here. You know, this cosmopolitan weed. It's found in South Africa in all but 2 provinces. The important thing about it, though, is that its ancestors are thought to be in Central and South America. So what you have here is Lantana camara is not really what you find back in the country, in the native country. So it's completely different genetically, and I think that's very important to take note in my discussion later on. But also one thing that's important about it is that in work that we've done before, we've actually found that there are physical induced responses. So besides the chemicals, some of these varieties, not all of them, some of them have the ability to induce in new growth. So when a herbivore is fed on lantana, in the new growth of its leaves, it is able to come up with more trichomes, harder leaves, etc. in new growth. So it's basically what we call phenotypic plasticity, the plant's ability to change its form in response to feeding. But also recently in preliminary work that I did, there was an indication, this was a little study, indication that chemicals are also induced. So volatile chemicals are also induced, but because of my collaborator that I was working with, he had to leave, so I couldn't really get to finish this. So the aims of this little study that I did was to take that work further. But what I did this time was to look at 2 types of mechanical damage, cutting and puncturing. Now, it's well known that feeding by an insect and mechanical damage doesn't always produce the same kind of responses. But mechanical damage can give you an indication of whether a plant is able to induce these responses, and I think that was the point that was my point of departure with this study. But also I wanted to find out the rate at which these responses are induced. Are they rapidly induced? How quickly after feeding is Lantana able to effect these responses, and how long does it sustain them as well? And so I had an opportunity last year to travel to Florida to a chemical ecology lab to get my head around all these new things which I had no background on before. And I worked with Greg Willer at the USDA lab up in Florida, and basically what we did is we ran an experiment, and we had